Well, this is the arrival from Hobby King. All the parts for the Quadcopter, all the main parts for the Quadcopter. Got the 4 35 series motors made by Turnigy. Pretty big. Excellent. Very low profile. Come in these very nice containers. All 4 of these ready to go. Got all 4 of the Afro ESCs with the Simon K firmware, which is very important. They're really small. It's amazing how small they are, actually. Very, very thin. And 30 amps apiece, which is pretty good. The 5,000 mAh battery packs, massive. This thing is huge. This is by far the biggest chunk of weight, about 350 grams. It's going to be the single largest thing on the quadcopter, so that's huge. 5,000 milliamps though gives me about an 80% efficiency, 82% efficiency, so should be good. The propellers, they actually sent me both red by mistake. At least the directions are different, so you can see that they are in fact reverse direction, which is what you want. But 2 of them were supposed to be green, or one pack was supposed to be green, and the other pack was supposed to be red. So that's a bummer. Sheet of carbon fiber. I believe this is 2 millimeters thick. Just for probably mounting my GPS antenna. Some standoffs for mounting that plate. The 4-to-1 wiring adapter for the 4 speed controllers. And last but not least are the parts for my Turnigy Talon V2, which I'm very excited about, and we'll assemble this very soon. Okay, so I skipped ahead a little bit and actually constructed the quad, actually done test flight, but I'm going to go back a little bit. Now that you've seen how it's been constructed, I'm going to go back and explain to you the electronics, starting with the motors and the speed control. Okay, so the first element you have is the motor, which this is an example of a brushless motor that you would use in a quad. And you'll notice it has 3 wires, typically red, black, and the third color, sometimes yellow, sometimes blue. This isn't a line for an RC helicopter that just happens to use blue. In this case, they use yellow as the third color. And so how it works is you have the speed controller, gets its signal from the receiver, goes into the receiver, which is in this case right here, gets power from the battery on this end, the red-black, and then feeds into the motor with these three wires. Brushless are a little bit different than standard non-brushless motors, and if you want information on that, there's a link below. It's a good resource for information on that stuff. So now in this case though, we actually have 4 motors, and therefore we have 4 speed controllers. In this case, I managed to house the 4 speed controllers in this lower section right here, which you can kind of see now. Each side has its power wire coming out the side. So the power distribution you can see coming out of the bottom of the quad right here underneath, and it connects all 4 of the battery leads from each of the 4 speed controllers into one larger gauge wire, which feeds into the APM power module, which then feeds directly into the battery. And the power module, like I mentioned in the last video, is what allows the APM module to know what's going on with the power. It also feeds a clean power line to the APM, but most importantly, really, it tells you what's going on with the battery. So next, what we've done, now that we've talked about how the power is distributed, remember last time I explained to you that the APM module has inputs and outputs. In this case, the information comes in from the radio receiver right here, and then all these channels go directly into the APM module. So the APM module actually controls everything into the inputs here, and then the outputs. In this case, all I have are the 4 outputs for the 4 motors. So now that you have the 4 motors hooked up, I'll explain to you the direction. In the case of a quad, the front right and rear left motors spin counterclockwise, and the front left and rear right motors spin counterclockwise. So what you have are the front 2 that oppose each other this way, and then the rear 2 that oppose each other in the opposite direction. And what that allows you to do is pivot. So if you want to pivot to the right, these 2, which are spinning clockwise, would increase in speed. And actually, sorry, it's the other way around. When you want to pivot to the left, these 2 would increase in speed, and since they're spinning this direction, just the rotational forces would cause you to rotate to the left, and vice versa. If you want to go to the right, these 2 would spin faster than these 2. Okay, so the next thing we're going to talk about is the wiring of the actual module on this particular aircraft. So as you can see, I've actually had to mill these custom wings out of carbon fiber on my CNC machine, which are necessary because there just isn't a whole lot of real estate to mount things to this frame. This frame I don't believe was ever really meant for all this electronics. In this case, I've got the APM, the GPS, they've got the 3D robotics radio module, and eventually I'm going to have the camera, which is going to be mounted right up here with its own battery, and also the video transmitter, which will probably be in the back. So I actually need to make another plate. But in this case, you can see the custom plates, the brackets that I made, which are fairly nice looking. They match the frame, and they do a good job of providing a great deal of space that I can mount different peripherals to. So far, all I have are the bare minimum. Now, the APM module actually needs to be isolated due to vibration dampening. So you need to actually do some kind of vibration dampening. In this, I've just got some foam that does a pretty good job. And then I actually have these blocks that raise up so it has freedom of movement, and I'll probably put a bigger pad. And then the GPS antenna goes right on top in the middle. And it's a very neat, tidy package, and I also had to create this carbon fiber bracket just to hold the GPS antenna. It looks nice, and again, it's consistent with the look of the quad. Okay, so the wiring's fairly straightforward if you've done RC before. We've already gone over power. We've already gone over signal coming out from the receiver into the APM module right here. These little receiver stubby cords, and that basically consumes all of the inputs on the APM module, and then the outputs go here. Now these other options here we have. This is actually the DSM antenna for the receiver. This little guy right here. So this just goes right into the receiver. Just because I have the DX9, which has the this is the AR8000 receiver, which is an 8-channel. Has this extra antenna. So a lot of that's just clutter, and then wires from the GPS antenna. The GPS antenna has two. One for the magnet, or for basically for the compass, and the other for the GPS signal. And those feed in on this side of the APM module. One right over here for GPS, and then one right over here for the magnet or the compass. The radio, the 3D Robotics radio module, just goes directly into the telemetry port right here, and then the power module has its connection right there, and that's it. And that's all for the basic connections. And I've already connected the the unit for the on-screen display, and I'll go over that in the first-person video that I'll make. So you'll get to see that in the next video. But for now, this is the completed MCC quadcopter drone. And like I said, I've already done a test flight, and I'll show you the teaser in a moment. After I do the first-person video, there'll be the first real flight, which you'll see very soon. So thank you for watching, and look forward to the next video. This was a long one, but I hope you got a lot of it. Thank you very much.